Let us start remaining numericals. In last period we solved 3 numericals on chemical equilibrium. Now we will going to start 4th numerical on heating 5 moles. I will write numerical on board on heating 5 moles of hydrogen with 2 moles of iodine, 2 moles of iodine, comma 3 moles of hydrogen iodide were obtained at equilibrium and at 300 Kelvin in a flask of volume 5 dm cube, calculate equilibrium constant for the given reaction. Simple numerical. Concentration is important. On heating 5 moles of hydrogen with 2 moles of iodine. Means reactants are hydrogen and iodine and their moles are given 5 moles and 2 moles respectively. Then reaction started, product formed, and at equilibrium 3 moles of hydrogen iodide is obtained. Means at equilibrium 3 moles of hydrogen iodide is obtained at 300 Kelvin in 5 dm cube flask. Volume is given 5 dm cube, and then our aim is to calculate equilibrium constant. Then from the given reaction, from the given information, we can write a reaction. H2 react with I2, equilibrium established to form twice HI. This is the balanced chemical equation from the given information. Then 3 points. First point, initial moles. Initial means when the reaction started. How many moles of hydrogen are given at initial stage? 5. Therefore, below H2 we have to write 5. How many moles of I2 at initial stage are given? 2 moles. 2 moles of I2. At initial stage, no product is formed. Therefore, number of moles of HI at initial stage are 0. Second point, that is very important, it requires full concentration to receive. Moles at equilibrium. How many moles of HI are formed at equilibrium? 3. And from this data, our aim is to calculate left moles of H2 and I2 at equilibrium. How? Listen carefully. Whenever the 1 mole of H2 get react, how many moles of H are formed? 2. Therefore, we will write H2 below 1, Hi below 2. For find out the left mole. Means whenever the 1 mole of H2 get react, how many moles of H are formed? 2 from the given reaction. Then how many moles of Hi are formed at equilibrium? 3. Therefore, how many moles of H2 get react? Question mark, cross multiplication. 3 into 1 divided by 2, and it is equal to 1.5. Means the reacted moles of H2 are 1.5. Then left mole, how many? We have taken initial moles 5. 5 minus 1.5. Initial moles are 5, reacted moles are 1.5. Therefore, left mole how many? 5 minus 1.5, and this will be the equal to 3.5. Left moles of H2 3.5. Then similarly, whenever the 1 mole of I2 get react, how many moles of H are formed? 2. I2 Hi 1 mole 2. How many moles of H are formed? 3. Then how many moles of I2 get react? Similar fashion, 3 into 1 divided by 2 equal to 1.5. Means reacted moles of I2 at equilibrium are 1.5. But given mole at initial stage 2. Therefore, left mole 2 minus 1.5 equal to 0.5. Means 0.5 moles are left. Means now conclusion. At equilibrium, how many moles of H2 are left? 3.5. How many moles of I2 are left? 0.5. How many moles of H are formed at equilibrium? 3. This is the second stage. Now third step is very simple. Concentration at equilibrium in moles per dm cube. In moles per dm cube. Now 3.5 moles at equilibrium. Given volume is 5. 3.5 divided by 5. 0.5 divided by 5, and then 3 divided by 5. This is the concentration of respective species at equilibrium in moles per dm cube. Right? And then apply the law of mass action to this given reaction. Applying the law of mass action we get Kc equal to concentration of Hi raised to 2 upon concentration of H2 into concentration of I2. Now we have the values of these concentration. Concentration of Hi 3.5. Concentration of H2 3.5 divided by 5. And concentration of I2 0.5 divided by 5. Substitute these values in that equation. Then 3 divided by 5 whole raised to 2 upon concentration of H2 3.5 divided by 5 into 0.5 divided by 5. We substitute values of these concentration in that equation. And then simple calculations. It is equal to, we will write 3 by 5 into 3 by 5 upon 3.5 upon 5 into 0.5 divided by 5. 5, 5, 5, 5 get cancelled. Just then multiplication. 3 into 3, 9. And then 3.5 into 5. 3.5 into 5. 5. We will write this fashion. 35 into 10 raised to minus 1. 5 into 10 raised to minus 1. Then it is equal to 35 गुणिले 5 means multiplication. 5 into 5, 9 divided by 5 into 5, 25, carry 2, 5 into 3, 15, carry 2, 70. 9 divided by 175, 10 raised to minus 2 in a numerator becomes 10 raised to 2. Then it is equal to 900 divided by 175. 900 divided by 175. Then it is equal to, simple answer, by doing the division, it is equal to 5.14. 5.14. And therefore, I will write here answer Kc equal to 5.14. This is your final answer. I will repeat the same in short. On heating 5 moles of hydrogen with 2 moles of iodine, 3 moles of HI were obtained at equilibrium at 300 Kelvin in a flask of volume 5 dm cube. And our aim is to calculate equilibrium constant. Means from the given numerical total 4 things are given. Initial moles of H2 5, initial moles of I2 2, and at equilibrium 3 moles of HI given, and volume is given 5 dm cube. Therefore, we return a reaction. H2 plus I2 gives twice HI. Initial moles 5, initial moles of I2 2, initial moles are 0. Moles at equilibrium 5 minus 1.5, because reacted moles of H2 is 1.5. Reacted moles of I2 1.5. Therefore, left moles at equilibrium 3.5, 0.5 respective spaces and 3. Then concentration at equilibrium in moles per dm cube divided by volume, because concentration is expressed moles per dm cube. Therefore, 3.5 divided by 5, 0.5 divided by 5, 3 divided by 5. Then we applied law of mass action to this reaction. We get this equation. Kc equal to concentration of HI raised to 2 upon concentration of H2 into concentration of I2. By putting these values, means we substituted values of these concentration in this fashion. 3.5 raised to 2, 3.5 divided by 5, 0.5 divided by 5. Then after simplification, we got these calculations, and final answer becomes 5.14. Therefore, equilibrium constant at 300 Kelvin for the given reaction is 5.14. I hope we got this numerical. Yes, any doubt? Yes. Let us start numerical number then 5. Numerical number 5. We discussed 4 numericals. Numerical number 5. In an equilibrium experiment, the following results were obtained. Following results were obtained. Result number 1, concentration of H2 equal to 8 into 10 raised to minus 4 moles per dm cube. Result number 2, concentration of I2 equal to 2.5 into 10 raised to minus 3 moles per dm cube. And third, concentration of HI equal to 1 into 10 raised to minus 2 moles per dm cube. Calculate equilibrium constant for the formation of the reaction for the given reaction. Reaction is given H2 plus I2 gives twice HI. Simple, directly concentrations are given at equilibrium, means if H2 react with I2 to form HI, equilibrium is established, and then their concentrations at equilibrium are given. Therefore, concentration at equilibrium are given in moles per dm cube. What is the concentration of H2? 8 into 10 raised to minus 4. Concentration of I2, 2.5 into 10 raised to minus 3. And concentration of I2, HI, 1 into 10 raised to minus 2. The next step, apply the law of mass action to this reaction. We get Kc equal to concentration of HI raised to 2 upon concentration of H2 into concentration of I2. Then simple again, by putting these values of concentration in that equation, we get 1 into 10 raised to minus 2 whole raised to 2 upon concentration of H2, 8 into 10 raised to minus 4, and concentration of I2, 2.5 into 10 raised to minus 3. Simple, substitute the values, then 10 raised to minus 2 means minus 4 get cancelled, and then it is equal to 1 upon 8 into 2.5 into 10 raised to minus 3. It is equal to then. Simple, do the multiplication. 10 10 raised to minus 3 becomes a numerator, then it becomes 1000. 8 into 2.5 equal to 20, and then simple answer 50, then 50. Therefore Kc equal to 50. This is your final answer. Simple calculations. Concentrate your eyes on each steps. In an equilibrium experiment, the following results were obtained. Means directly results are given. H2 react with I2 to form HI, and then equilibrium concentrations were obtained. Concentrations of H2, I2, HI are 8 into 10 raised to minus 4, 2.5 into 10 raised to minus 3, 1 into 10 raised to minus 2 respectively. And from this our aim is to calculate equilibrium constant. Then we return reaction H2 plus I2 gives twice HI. Then concentrations at the equilibrium in moles per dm cube are given. We return these concentrations from the given information. Then we applied law of mass action to this reaction. We get this equation Kc equal to concentration of HI raised to 2 upon concentration of H2 into concentration of I2. By putting the values of these concentrations, 1 into 10 raised to minus 2 whole raised to 2 upon 8 into 10 raised to minus 4 into 2.5 into 10 raised to minus 3. Minus 2 into 2 minus 4. Minus 4 get cancelled. Then it becomes 1 upon 8 into 2.5 into 10 raised to minus 3. This 10 raised to minus 3, when you transfer towards numerator, it becomes plus 3, means that is 1000. Then we return 1000. Multiplication 8 into 2.5, 20. Therefore 1000 divided by 20 is nothing but 50. Therefore equilibrium constant for the given reaction is 50. Right? Simple numerical. Any doubt? Yes. Then let's start the next sixth numerical. SO3 is placed in a 5dm cube. SO3 is placed in 5dm cube flask. 5dm cube flask. Then 0.125 mole of SO3 comma 0.25 moles of SO2 and 0.5 moles of O2 oxygen are present at equilibrium. Calculate equilibrium constant. Calculate equilibrium constant for the reaction. Now concentrative version this numerical. SO3 is placed in 5 cube flask. Means reactant is known. Reactant is SO3. Then reaction started, SO3 decomposed. Then after decomposition, after the reaction equilibrium established, two products are formed. Product number 1 sulfur dioxide and product number 2 O2. And then at equilibrium their moles are given. 0.125 moles of SO3 at equilibrium, 0.25 moles of SO2 at equilibrium, and 0.5 moles of O2 at equilibrium are found. And therefore, from the given information we can write reaction SO3 decompose to form SO2 plus O2. To balance the reaction, because oxygens are not balanced here, 2 into 4, here 3. Therefore, 2 times SO3 gives 2 times SO2. 2 into 3, 6 oxygen atoms. 2 into 2, 4. 4 plus 2, 6 oxygen atoms are balanced. 2 times sulfur, 2 times sulfur. Sulfur are also balanced, right? Then, moles at equilibrium are given. How many moles of SO3 are given? 0.125. How many moles of SO2 are found at equilibrium? 0.25. How many moles of O2 at equilibrium are found? 0.5. Means these are the moles of respective species are found at equilibrium. And second steps, concentrations at equilibrium in moles per dm cube. Because we know concentration, I will repeat the same, concentration is expressed in moles per dm cube. Dm cube, volume is given 5 dm cube. Therefore, if you divide moles 0.125 by volume, volume is 5. Then it is concentration, moles per dm cube. 0.25 upon 5 moles per dm cube, that is nothing but concentration, right? Because concentration is nothing but number of moles of solute per unit volume. Moles are given, volume is given. Ratio is nothing but concentration. 0.5 moles divided by 5. These are the concentrations of these species at equilibrium. Then next step known was apply the law of mass action to this reaction. We get Kc equal to concentration of SO3 raised to 2 upon concentration of SO2 raised to 2 into concentration of O2. We applied law of mass action to this reaction. We get that equation. Now we have the values of these concentrations. These are the values of concentrations, right? Then by putting these concentrations in that equation, we can write concentration of SO3 0.125 upon 5 raised to 2 upon SO2 0.25 upon 5 raised to 2 into O2 concentration 0.5 upon 5. Concentration of SO3 0.125 divided by 5 whole raised to 2. SO2 concentration 0.255 by 5 raised to 2. And O2 concentration 0.5 divided by 5. Right? Then simplify it. After simplification, we get, if we divide moles per dm cube, then it becomes ratio 25 divided by 5. 0.25, 0.25 SO2, then square of this, yes, this 5, 5, 5, 5 get cancelled. Then it is equal to 0.125 into 0.125 upon 0.25 into 0.5 divided by 5. This 5 get cancelled, left 10 raised to minus 1. Then it becomes, if the point if in this side, then 0.125 into 0.125 upon 0.025. By shifting the 10 raised minus 1 point percent, it becomes this ratio. Then after doing the calculation, we get square of this. Square, after putting this equation, we can write here 125 into 125, here 10 raised to minus 3 into 10 raised to minus 3 upon 0.25 means 25 into 10 raised to minus 3. This 10 raised to minus 3, 1, 10 raised to minus 3, 1 get cancelled. And then square it. By doing the calculation, (125 into 125 equal to 15,625 divided by 25. Then it becomes 625. Then 10 raised to minus 3. Therefore, answer becomes, I will write here answer, Kc equal to 625 into 10 raised to minus 3, that is nothing but 0.625. This is your final answer. Equilibrium constant equal to 0.625. I will repeat the same in short. SO3 is placed in 5 dm cube flask. Then 1.125 moles of SO3, 0.25 moles of SO2, 0.5 moles of O2 are present at equilibrium. Then our aim is to calculate equilibrium constant. SO3 is placed in a 5 dm cube flask, means reactant is SO3 to form SO2 and O2. To balance, we return 2, 2. Then moles at equilibrium are given. SO3 0.125, SO2 0.25, O2 0.5. Then concentration at equilibrium moles per dm cube 0.125 divided by 5, volume is given 5, 0.25 by 5, 0.5 by 5. After applying the law of mass action to this reaction, we get that equation Kc equal to concentration of SO3 raised to 2, concentration of SO2 raised to 2, concentration of O2. By putting the values of these concentrations, we have the values of these concentrations, we substitute, and by doing the calculations, final answer becomes equilibrium constant equal to 0.625. right? I hope you are getting me, right? Let us start then today's last numerical. It is for your homework. Do the home with full concentration. Numerical number 7. 1 mole of PCl5 is heated in a closed vessel is heated in a closed vessel when equilibrium is attained point 4 moles of PCl5 dissociates into PCl3 and Cl2. Full stop. Calculate equilibrium constant for the reaction. Yes, this is your homework. Do at home carefully. I will write in bracket answer and tally with this answer. Kc equal to 0.133. Answer of this numerical, equilibrium constant equal to 0.133. In this way, we completed first topic, chemical equilibrium of first section. Yes, this line indicates end of the first topic of first section of chemistry, 11th chemistry. Yes, I hope you are getting me. Thank you.